All right, so we are going to talk about graphing linear inequalities, and this is IXL T3. And this one is actually interesting because it starts with a single variable inequality. Like here we have x is bigger than 2. And if we think about this on a number line, it would just be an open circle at the number 2, and all the things that are bigger than 2 are 2.5 and 2.25 and 3 and 5 and 10. And numbers get bigger to the right, so it would be an open circle at 2, and we would say shaded to the right. But because we're on a graph that has both the x and the y axes, in this case, it's going to look the same, except it's going to be a vertical line. So it's going to be at 2, and I need to click 2 points here because I have 1 point, but to make a line, to define a line, I need 2 points. And I need it to be an open circle, but it's a line, so we say an open line looks like a dotted line. And then I would shade, so here I can shade, and that's to the right. And that's because I want all of the x values that are bigger than 2. Everywhere here, x is equal to 2, but I want everything that's bigger than 2, so that would be 3 and 4 and 5 and 6. All right, here I want y values that are bigger than -2. So this is actually going to be a horizontal line, because if I think about my formula or my equation of slope-intercept form, if there's no x term, that means that the x has gone away, and the only thing that can make x go away is if the slope is 0. And if my slope is 0, it's a horizontal line. Here it's at -2, so I'm going to click at -2. I'm going to click a second point to define my line. Because this has an equal to underneath it, it's a solid line, so I'm going to keep the solid line rather than changing it to a dotted line. And I want everything that's bigger than -2. Well, as things go up on the y-axis, they get bigger, so it's going to be shaded above. Okay, for here, now I've started to get into two variable inequalities. So this is the first problem, this is the third problem, and now all of a sudden I have both y and x. Now this resembles our y equals mx plus b, except I don't have a b value. If you remember that b represents our y-intercept. So I don't have a y-intercept here, so that means that I need to start at the origin. And this -3 in front of my x represents that that's my slope, -3/1. So I'm going to start at 0 because that's my y-intercept, or my b value. Because I have a slope of -3/1, that means I'm going to rise -3, which is actually falling down 1, 2, 3, and over to the right 1. I'm going to click my second point to define it. So if we check this, it's a slope of down 3 and to the right 1. Because it has an equal to here, that means it's going to be a solid line, so I'm not going to change the line. I'm going to keep it solid. And I want everything that's smaller than, and a lot of times I tell my students, or everything that's below this line. When it's a less than symbol, I want everything below the line. A different way of thinking about it is you can actually cross off that term, this x term, and if I had a 0 here, I want all the y values that are less than 0. Well, that's everything down here. So I'm going to click the shaded area down here, and we've now done 3. So this one's going to be really similar. My b value again is 0. My slope is 3/1, so instead of being a negative slope, this time it's a positive slope. So I'm going to go up 3 and to the right 1. So there's my slope. However, the difference is that this does not have an equal to, so it needs to be a dotted line. And I need to again shade below the line. And so because it's a less than symbol, I'm going to shade below the line or down from the line. And that would be this area here. Continuing on, now I finally have a linear inequality that has both y and x. It resembles my y equals mx plus b, where my y-intercept here is -4. So I'm going to start at -4 on my y-axis. The thing in front of my x is actually, my students taught me, they say that this is a ghost 1 or a phantom 1. So I would say it's -1/1, which is the same as saying I'm going to fall or rise -1, go down 1, and to the right 1. So it has a slope of -1. Because this doesn't have an equal to below it, it's going to be a dotted line, or solutions will not fall on this line. And it's a greater than symbol, which means I want to shade above my line. And so this is kind of one of those nice examples that if I ignored this term and I just read it as y's that are bigger than -4, everything that's bigger than -4 is above it. So -3, -2, 0, all those y values are bigger than -4. That's why I'm shading up. Here I have y's that are greater than or equal to -6 or -x plus 6. So my b value, my y-intercept is 6. My slope is -1/1, so I'm going to go down 1 and to the right 1. So that is a slope of -1. I have a solid line because I have an equal to, so solutions can fall on this line. And I'm going to shade above because all my solutions are going to be in the shaded area above. That's because I want everything that's bigger than 6, and things that are bigger than 6 are 7 and 8, so that's where we know the solutions lie. All right, here is my next one. It's y's that are less than or equal to -2x plus 4. So my y-intercept is at +4, so I'm going to start there. My slope here is -2/1. So -2/1, which means I'm going to go down 2 into the right 1. Down 2 to the right 1, that's a slope of -2. Because that's an equal to, my solutions can lie on the line, so I'm going to keep it as a solid line. And I want it to be less than, which means my solutions are all the values that if I ignore this term and I just read it as y's that are less than 4, well, that's all the values below the line. All right, continuing on, I have a y-intercept here of 3. Whoops, I don't want that. If I ever make a mistake, I can just, like I did there, I clicked on 2, but I knew my y-intercept was 3. If you just re-click on the dot, it will undo it. So here's my y-intercept of 3, and I want a positive slope of 4/1. So I'm going to go up 1, 2, 3, 4, and over to the right 1. Because it doesn't have an equal to, my solutions can't fall on this line, so it's going to be a dotted line. And I'm going to shade below this line. I'm going to click below the line and shade below the line. All right, so I always tell my students that we want to go to a 90. I make my IXLs out of a 90, so I'm getting closer. I've only answered 8 questions, about 9 minutes, so really not that bad as far as the amount of time that we've taken to do this. Here my inequality is y's that are greater than 2x plus 1. I need to start at +1 because that's my y-intercept, move up 2 and to the right 1 because I have a slope of 2/1. It's going to be a dotted line because solutions can't fall on this line, and it's going to be everything above that line. Now, if you make a mistake or you get a problem wrong, that's okay. Don't get frustrated. Just keep trying. And if you get stuck, you can always come and ask me or send me a question. So this problem, y's are greater than or equal to 3x plus 1. If I start at +1, which is my y-intercept, I have a slope of up 3 and over 1. So I'm going to go up 3 and to the right 1. Because it's an equal to, that means I am going to have a solid line, and I'm going to shade above this line. So you can tell I'm kind of moving faster now. So this is the first problem where I have an inequality, but it's not solved for y. So for this problem, I actually need to solve for y. And the first thing I'm going to do is actually to get y by itself, I always tell my students to box in the variable and draw a line. So I need to subtract x from each side. And if I subtract x from each side, well, the x's on the left side, 1x and -x, those are become a 0 pair. They cancel out. And over here, I can't take away x from 1, so I just have to rewrite it as y's that are less than or equal to -x plus 1. So when I've rewritten it, I can now see that my slope is -1/1, and my y-intercept is at +1. So I'm going to put my first point at +1, my y-intercept. Because I have a slope of -1/1, I'm going to put my second point, which is down 1 and to the right 1. It's an equal to, which means my line is going to be solid. So I'm going to keep it as a solid line. And I need to shade below because that's where all my values are less than 1. And all right, so again, I have a problem that is not solved for y. I need to get y by itself in order to have it in slope-intercept form to graph it. So in this case, I have a 3x on the left-hand side. That's on the same side as my y. to get rid of that 3x, which is a positive 3x. I'm going to subtract 3x from each side. So now I have y is less than negative 3x minus 6. I can't combine the negative 3x and negative 6. They're not like terms. That would be 3 shaded rectangles and 6 small little squares. I've rewritten my problem, so now I can start to graph it. So I want to go down to negative 6 on the y-axis, because that's my y-intercept. So I'm going to go down to negative 6. And I know that I have a slope of negative 3, which is down 3 and to the right 1. So down 3 to the right 1. It's going to be a dotted line because solutions cannot lie on this line. It doesn't have an equal to, so I'm going to click on my line and try to change it to dotted. And then I know that my solutions are going to be below this line. So I'm going to shade the area below this line. And so at this point, I'm actually going to, end this video. We've done 12 questions together. You guys have gotten to a 75 just by watching and kind of going through this. Like I said, the first 2 questions that are just single variable inequalities are probably maybe the more challenging of problems, just because we have to recall if it's a horizontal or vertical line based on which variable is in the inequality. But this is a video again on how to graph 2 variable linear inequalities, and I hope this helped you. Have a great day.